Okay, imagine a computer that's, say, 100 times faster than the one you're using right now, and it barely even gets warm. Sounds like something out of a sci-fi movie, doesn't it? Well, it might be a lot closer to reality than you think, all thanks to this incredible new piece of tech called a nanolaser. So let's dive in and see how this tiny device could solve one of the biggest headaches in modern computing.
I mean, we've all been there, right? You've got your brand new phone, your powerful laptop, and then it happens. It starts getting hot, that little fan kicks on, and everything just slows down. But why? I mean, with all the amazing technology we have, why is this still such a huge problem? Well, the answer is hiding deep inside the microchip.
And that really gets us to the heart of the problem. It's something called the electricity bottleneck. You see, the very thing that makes our digital world go round, that flow of electrons, is actually the thing that's holding it back. So picture this. Think of the inside of a microchip like a giant, sprawling highway system. And the electrical signals? Those are all the cars. Now, what happens when you try to cram more and more cars onto that highway? You get gridlock, right? Traffic jams. All those engines create a ton of heat, and you're just burning fuel going nowhere. Well, that's exactly what's happening inside our computers. That electricity generates heat, it wastes energy, and it creates a very real speed limit for our data.
So if our electrical highway is jammed, what's the solution? Well, what if we got rid of the cars altogether and used light instead? I mean, the difference is just night and day. Electrical signals create a ton of heat. Light creates basically zero. Electricity is fast, sure, but it has limits. Light moves at, well, the speed of light. And all that energy wasted by electricity, light is super efficient. The advantages are just obvious.
Okay, so using light sounds great in theory, but how on earth do you make that happen inside a microchip that's smaller than your fingernail? Well, this is where the story gets really cool. Researchers over in Denmark have come up with a breakthrough nanolaser that might just be the hero we've been waiting for.
Yeah. A team at the Technical University of Denmark, or DTU for short, has built a laser that is just unbelievably small. And when I say small, I mean you could pack thousands of them onto a single microchip. This isn't just a small step up, no way. This is a complete game changer for how we design the engines that run our entire world.
And listen to what the lead researcher, Professor Jesper Mørk, had to say. He put it perfectly. The nanolaser opens up the possibility of creating a new generation of components that combine high performance with minimal size. So what's that mean for us? It means getting way more power, but in a package that's smaller and way more efficient.
All right, this all sounds pretty mind-blowing, I know, but how does it actually work? I mean, how do you even build and control a laser that's that tiny? Well, the secret is all about a really clever way of trapping light.
The magic ingredient here is something called a nanocavity. Now, the best way to think of it is like an echo chamber, where sound bounces all around and gets louder. This does the exact same thing, but for light. It's this tiny structure with a special pattern of holes that traps light particles, photons, and makes them bounce around like crazy, amplifying them until, bam, you get a powerful laser beam in a space that's almost impossibly small.
And the process itself is surprisingly simple, really. It breaks down into 3 basic steps. First, you hit it with a little bit of light to get things started. Second, that light and some electrons get trapped and squeezed together inside that nanocavity. And third, and this is the truly incredible part, the whole thing just works, right at room temperature using almost no energy. It's just a beautiful, elegant solution.
Okay, so we've got this tiny, super efficient laser. Big deal, right? What does that actually mean for you and me? Well, this is where things get really exciting, because the impact this could have is just massive. We're not talking about a future that's just a little bit better. We're talking about one that's way faster and a whole lot greener.
50%. Just let that number sink in for a second. 50%. That's how much this could potentially cut down the energy our computers use. This isn't a tiny improvement, folks. This is a giant leap.
Now, to put that number into perspective, we are talking about the possibility of cutting the power bill for the world's data centers in half. Those giant server farms that power the internet? They currently use about 1% of all electricity on the entire planet. That's a huge number. And that's before we even talk about the savings for your phone, your laptop, every single device you own. The positive impact on the environment could be absolutely staggering.
And believe it or not, it doesn't even stop there. We're not just talking about faster computers and saving energy. This same tech could lead to things like way sharper, higher resolution medical scans. It could give us super sensitive biosensors to detect diseases earlier.
I mean, the potential applications just go on and on across so many different fields. This could really change everything.
Now, of course, with any breakthrough this big, it's not like it's ready to go tomorrow. There's always another challenge, right? One last big hurdle to jump before it can really change the world. So, what's holding the nanolaser back?
Well, right now, to turn on the nanolaser, you have to shine another laser on it. And for this to actually work inside our phones and computers, it needs to run on plain old electricity. So that's the next big puzzle for the researchers to solve. How do you plug this tiny little light engine into the same electrical grid that powers everything else on the chip? So how long are we talking? Well, today, we've got this amazing proof that it works. The researchers themselves say their goal is to crack that electrical power problem and have this ready for the real world in about 5 to 10 years. So, you see, it's not just a sci-fi dream. This is actually on the horizon.
And that just leaves us with one last, kind of amazing thought to chew on. For the last 100 years or so, our entire world has been built on the electron. But maybe, just maybe, we're reaching the end of what electricity can do for us. It makes you wonder, right? Could our future, our computers, our networks, our next great leap forward, be built not on electricity, but on light?